Today I'm going to talk about the data visualization and exploratory data analysis. I will use the data from chemical computation, house price prediction, use regression techniques. So I choose to use Python because I applied machine learning techniques using Python before. So to keep consistency, I'm going to use Python. Actually, I have seen a lot of methods in GitHub or Kaggle discussions, but I have ever seen some detailed open source CDA code. So therefore, I'm going to use those techniques learning class to learn about some numerical and calculable data and do some exploratory data analysis. So first, let us import packages. So I'm not going to take you to go through the data in detail because there's a lot of features. So if you're interested, I will put the link below. We'll import the dataset, trans data, test data, and to split the y value, we will split it. And because we're going to import the data analysis, so we'll concatenate those trend test data. So you know, like the ID column is useless. So let's see this dataset a little bit. A lot of features. Yes, there's quite a lot. So it's very complicated. So there are two features, which misfeature, misvalue, and we can see what those values are. Misfeatures are features not covered in other libraries. So these will be complicated because some feature has those, some feature doesn't have. So we will drop those directly. And let's see what we get. We get a flow data set, which has like 77 columns. And we'll see the data types as integer and float and object. And normally the integer will be discrete values, the float will be continuous values, and object will be categorical values. In real situation, and we're going to see it in detail. So these are discrete features. And we'll see, for example, the main subclass. It's a building class, the house building class. So it's all the integers. It's not will be like 60.4 or other things because different classes. So those are continuous values. Those are numerical features. So 18 continuous features, 17 discrete features, and those are categorical features. So you maybe wonder what it is. The categorical features, you can look at that. They have some features which has almost 3,000 variables. So what it is, you can find some features. The NA is also a well-known library. But the Python took it as a null value. So what we're going to do is we need to convert those null value into some category. So that is what we do. We're filling the null value with null. It's another category. So after doing the transformation, we can find, look, there's only some columns with null value, but the other this column, they're filling with null. So they're not null values in those columns. So I will print out discrete features 17, continuous features 18, and categorical features 44, 42. So I will can the missing values. So what I'm going to do is I need to drop rows because from this null count, you can find some columns has those columns has 1, 2, 4 null values. This very few. So I'm going to drop those rows. So what we do is drop those rows. And after doing that, yes, and pay attention, we only need to drop rows of trend dataset because the test data for every row we need to give a prediction. So do not drop the test data rows. Yes, so drop indices are those, and it's gonna be better. So after doing those, there are still some missing value columns. We find all of them. Those are those columns, and it has some continuous, it has some categorical. So for numerical for continuous values, we need to plot the histogram. So this is what I do here. I plot it, and you can find those are discrete values, and those are continuous values. But you can find 200, 250, or 300 has outliers. It may have some outliers. So what we're gonna do, we're not drop rows, but for some potential outliers, we're gonna use some boundary values to replace it. So those are boundary values I chose, and those are columns are potential outliers. So after doing those, we can find those are normally distributions similarly, and you can say those maybe similar non-distributions. So that would be good, and we can fill in missing values with a median. It will be better after we remove the outliers. After doing those, it's good, and we're going to go with the categorical values. We drop the bar chart. The bar chart is for categorical values distribution. So we can find some variables it has almost one variables in the future has all the counts, and it has almost no counts. So that features are insignificant because we cannot predict from this. Those features are also. So for those features, we are going to remove it because it's insignificant for our prediction. So after removing, we have those features previously what we analyze is single feature distribution, and we're going to analyze the distribution between x and y. So we drop the y, and those are discrete values, continuous and categorical only certain that. So those are the scatter plots between the y, and we'll find the y sale price, the y value, and one feature. So where's y value sale price? You can see that positive, but some columns no significant positive relationship, no significant, and those features we need to remove. So for y value and the categorical features, we need to drop box plot, and I draw it, and we'll see. I find those features are good because they have different means, but this feature, you can see that all the categories in one feature has almost the same sale price. What does this mean? This means that this variable is almost insignificant for the sale price, which in other words is not important for our prediction. So let's see those columns. The M also, you can see that the year sold also. So I will remove those columns. So this is what I do. I print, get the final result. Discrete length is only 14 that, categorical is 39 that, and the continuous only 18 that. So that is basic data analysis and data visualization. It will be powerful and useful. Thank you.